All right, so even though this says 1.5, this is 1.8 in our book. We are going to be dealing with combinations of functions. So just as two real numbers can be combined by the operations of addition, subtraction, multiplication, and division to form other real numbers, two functions can be combined to create new functions. So when we have a function f of x and g of x, you can form the sum, difference, product, and quotient of f and g as follows. So when taking the sum, all we do is add our two functions together. When taking the difference, we just subtract our two functions, but we have to be careful. If we have a binomial in our second one, we just have to make sure that this negative sign gets distributed to both things in our parentheses. If we are multiplying two functions and they're both binomials, we just have to FOIL. And then dividing, we just put one function over the other. And we have to make sure that our denominator does not equal 0. We can't have 0 on the bottom, so this cannot be 0. The domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domain of f and g. In the case of the quotient, there is a further restriction that g of x cannot equal 0. So again, we can't have 0 on the bottom. So our domain is going to be the domain that's common between the two. And then if we're dividing, we have a further restriction that we just can't have 0 on the bottom. So moving over to the right side of our page, we have the sum, difference, product, and quotient of functions. So the sum, we could write it two different ways. We can say f plus g of x or f of x plus g of x. So these are just two different ways of writing the same thing. We have f minus g of x, which is just f of x minus g of x. We have f times g of x, which is just the same thing as f of x times g of x, and then f over g of x is f of x over g of x. So these are just the same thing, just written in a different notation. So going to example 1, we are finding the sum of two functions. So we're given f of x is equal to 2x plus 1, and g of x is equal to x squared plus 2x minus 1. And we need to find the sum of the functions. So when adding the two functions, we just add them together. So we have f of x, which is 2x plus 1, plus g of x, which is x squared plus 2x minus 1. And now to simplify, we just combine our like terms. So we start with our x squared. There's no other x squared. Then we combine our two x's together. 2x plus 2x is 4x. And then we have 1 and minus 1, which is just 0. So our f plus g of x is equal to x squared plus 4x. Now to evaluate the sum when x is equal to 2, we just plug 2 in for x. So our f plus g of 2 is going to be 2 squared plus 4 times 2. So all we're doing is taking that 2 and plugging it in for x. So 2 squared is 4, plus 4 times 8, 4 times 2, which is 8. So here our answer would be 12. Okay, our next example is subtracting our functions. So we need to find f minus g of x and then evaluate the difference when x is equal to 2. So first we need to find f minus g of x. So we take our f of x, which is 2x plus 1, and subtract our g of x, which is x squared plus 2x minus 1. So here it's super important that we distribute our negative sign, our minus sign that's in the middle, to everything in the parentheses behind it. So we have 2x plus 1. This becomes a minus x squared, and then a minus 2x, and a plus 1. Now we combine our like terms. So we have negative x squared. We have no other x squared, so that's all by itself. What do we have next?
Negative 4x. Oh wait, no, nothing. Just plus 2.
Right, so the 2x and the negative 2x cancel each other out. And then we have 1 plus 1, which is plus 2. Awesome. And now we need to find our f minus g of 2. So we just take 2 and plug it in. So we have negative 2 squared plus 2. It's important that this negative stays on the outside and that you square the 2 first and then just put that negative with it. So a lot of people made this mistake on the quiz that you did negative 2 squared, which would be a positive 4. But here this negative is on the outside, so it just has to stay on the outside until we square our 2, and then we attach it to the 4. So 2 squared.
Would it ever be on the inside?
It would be on the inside if you were plugging in negative 2.
But if it wasn't specifically a negative 2, then it would be on the outside.
Right, if you were plugging in a negative, like let's say we had f of negative 2, and this was x squared. We would plug in our negative 2 to the inside, that would be squared. But if the negative is on the outside, it stays on the outside. So that negative is just not being squared. So here we have negative 4 plus 2. Negative 4 plus 2 is what?
Negative 2.
Negative 2. So our f minus g of 2 is negative 2. Any questions here?
Would there ever be a question that doesn't give you a function to work with? Like you'd have to remember the other way to write it?
You would have to remember the other way to write it? I don't understand your question.
Like the f minus g and the x, would they not give you that in a question? And you just have to remember?
They would give you, they give us 2 functions, and then this is telling us what we need to do to those 2 functions. So this is like part of the question. So they would always give you this part here.
Okay.
So like in the first one, it told us that we had to add the 2 functions. In this one, we have to subtract, and the next one, we're going to multiply. So it'll tell us what we need to do, which is part of the question. Does that answer your question?
Yeah,
Okay.
It does. Thank you.
You're welcome. So looking at example 3, we need to find the product of 2 functions. So here we're multiplying. So we're given f of x is equal to x squared, g of x is equal to x minus 3. We need to find f times g of x and then evaluate the product when x is equal to 4. So f times g of x just means that we multiply our two functions together. So we have x squared times x minus 3, and that's it. So we need to multiply them, so we have to distribute this x squared to both things inside our parentheses. What do we get when we distribute?
X cubed minus 3x squared.
Awesome. X cubed minus 3x squared. And then now we can plug in 4. So we have f of g of 4. So we have 4 cubed minus 3 times 4 squared. So 4 cubed would be 4 times 4 times 4, so this is 64. 4 squared is 16, and 16 times 3 is 48. What's 64 minus 48?
Uh, 16.
16. So our answer here is 16. So in examples 1 through 3, both f and g have domains that consist of all real numbers. So the domain of both f plus g and f minus g is also the set of all real numbers. Remember that any restrictions on the domain of f or g must be considered when forming the sum, difference, product, or quotient of f and g. For instance, the domain of f of x is equal to 1 over x is all except when x is equal to 0. So x cannot equal 0, and the domain of g of x is equal to the square root of x is all the positive numbers. So from 0, including 0 to infinity, this implies that our domain of f plus g is 0 to infinity. So looking at that on a number line, let's say. So if we have 0, 1, 2, -1, -2. So our domain of f of x cannot equal 0. So we would have a hole here, and then it's all of the numbers to the right and all the numbers to the left. Our domain of g of x is including 0 to infinity. So it would be from here to infinity. Our domain of the combination of the two has to be what's included in both domains. So here, since 0 is not included in our first domain, we cannot include 0 in our domain of the combination. So it would only be what's included from here to infinity, so forever. But since 0 was not included in the first one, we can't include it in our combination, so we have to have that parentheses instead of a bracket, just saying that it's from 0 to infinity, but not including 0. So our domain of our combination just has to be what's in common between the two domains of our functions.
How does this work in with the functions we're doing right now? I don't get what they mean by the domain and all that.
It will apply to the next example, especially the ones that we've done so far. The domains have always been all real numbers. So like for x squared, there's no restriction on that domain. It's the domain of x squared is all real numbers. The domain of x minus 3 is all real numbers. So our domain of our f times g of x is all real numbers. But it'll apply especially when dividing, we'll have this issue. And if we had, like in this example here, a fraction, so we can't have 0 on the bottom, so that's where we have to make sure we say our domain does not include 0. Or if we had a square root, we know that we can't have negatives on the square root, so we would have to say our domain here is from 0 to infinity. So it would apply if our functions looked like these two. So looking at example 4, here is when we'll have to state our domain. So given f of x is equal to the square root of x and g of x is equal to the square root of 4 minus x squared, we need to find f divided by g of x, then find the domain of f divided by g. So first we need to state our domain for f of x. What do we know about the square root of x? What does our domain have to be?
It can be anything, right, except 0.
Can we take the square root of a negative number?
No.
No.
So all positive numbers?
Right, so including 0, because we can take the square root of 0, which is just 0. We just can't take the square root of a negative number. So including 0 to infinity. So that's our domain for f of x. Now we need to find our domain for g of x. So we know we can't have a negative under the square root. So what we're going to do is set f minus x squared equal to 0. Setting it equal to 0 is going to help us find our key numbers, which will help us find our domain. So we just solve for x here. So I'm going to add x squared to both sides. So I have 4 is equal to x squared. Then I'll take the square root. What's the square root of 4?
2.
Just 2?
Yeah.
Plus or minus 2.
No. Oh, plus or minus 2.
Right, because we could take negative 2 and square that and still get positive 4. So it has to be plus or minus 2. So positive 2 and negative 2 are our key numbers here. So we need to figure out if our domain is in between these two numbers or outside these two numbers. So if we had a number line, the points we're looking at are negative 2 and positive 2. So our domain is either going to be inside these two numbers or outside these two numbers. And we can test that out by plugging numbers in. So picking a number that's outside of negative 2 and 2, we could pick negative 3. So if we plugged in negative 3 into our square root of 4 minus x squared, we would have the square root of 4 minus negative 3 squared, which this would be the square root of 4 minus 9, which is the square root of negative 5. We can't have the square root of a negative, so negative 3 would not be in our domain. So we can put a big X here because we know our domain's not going to include the outside here. Now we can pick a number inside of negative 2 and positive 2. So what would be a number inside negative 2 and positive 2?
Negative 1.
Negative 1. We could also pick 0, but negative 1 works too. So we would have 4 minus negative 1 squared. Negative 1 squared is positive 1, so this is 4 minus 1, which is the square root of 3. Here we have a positive number, so this works. So we can put a check mark there because we know that in between here works. So that can be part of our domain. And now let's try above. So again, outside on the positive side. What's a number outside a number outside of -2 and 2 that we can plug into text.
+3.
+3. So we have 4 minus +3 squared, which again is going to be -5, so this does not work. So our domain here is going to be in between -2 and +2. So how would we write that as our domain?
You would write -infinity to 2.
So we're just looking at numbers from
Oh, no. Yeah.
in between here. So
That's
from
just
-2.
to 2.
Right, do we put brackets or parentheses?
Parentheses.
Are we including
Because you-
+2 and -2 or not?
You are, so it's brackets.
Awesome, so it's brackets. So we have -2 to 2 as our domain here. So that would mean our domain for both of them, which I'll do on the side over here, has to contain the common numbers between these two domains. So on our number line, we have 0, 1, 2, 3, -1, -2, -3. So our domain for f of x includes 0 and goes to infinity. Our domain for g of x is only from -2 to +2. So what are numbers that we have in common here?
Zero to 2.
Awesome, 0 to 2. Do we put brackets or parentheses?
Brackets.
Brackets. So we're including both 0 and 2, so we would put brackets. So this is going to be our domain of our combination of the functions, but since we are dividing here, we also have another restriction where we can't have 0 on the bottom. So this is our domain for now until we find out what our f over g is. So let's figure out what our f over g of x is going to be. So we put f on top, so this is the square root of x over the square root of 4 minus x squared. So we know we cannot have a 0 on the bottom. So we need to figure out if we have a 0 on the bottom, is that part of our domain? And do we need to add that restriction as well? So we're going to set the square root of 4 minus x squared equal to 0, because we know it cannot be 0. So I'm going to put just a cannot be equal to 0 here, so we know that this can't be 0. And we're going to solve it the same way as we would if it was equal to 0. So we're solving for x, so we need to square both sides to get rid of that square root sign. So we have 4 minus x squared, and that does not equal 0, because 0 squared is 0. And then we can add x squared to both sides. So we have 4 does not equal x squared. We then need to take the square root of both sides. What's the square root of 4?
2.
Just 2?
Plus or minus 2.
Plus or minus 2. So x cannot be +2 or -2. Does our domain here include +2 or -2?
Yes.
Yeah, it includes that +2. But we said x cannot be +2, so we just have to add that restriction to our domain. And we would do that just by changing our bracket for the 2 to a parentheses, because this says that we can include everything from 0 to 2 except 2. So this is our function. And then this is our domain. Our domain is only what's in common, and our g of x, so this blue line represents the domain for g of x. Our g of x cannot have numbers higher than 2. So it doesn't go to infinity, so that's why it can't be in our domain down here. So our domain of our combination function is only what's in common. So the only parts that were common were from 0 to 2. And then once we figure out what our f over g of x is, we know we can't have 0 on the bottom, so we just have to add that restriction to our domain.